Okay, so we're going to look at if statements. These allow the program to make a decision based on some given criteria. So in the simplest possible way, we could specify a boolean value. So we could say something like boolean, let's say we wanted to tell whether or not we need an umbrella because it's raining. So we'll say raining, or maybe even better, is raining, to make our code read nicely. And for now we'll look out the window and we see it's not raining outside, so we'll say false. And then what we can do is we can write our if statement like this. We can say if, and then we follow it by a set of brackets, and then we put the boolean value in there. Okay, so we'll say if is raining, and then we have a set of braces. Okay, on here, and I'll put the closing brace in for me. So only if is raining is true will the code in here execute. So we could put in a statement to take an umbrella, and we'll run that. And we'll see our program just exits with 0, no code is output, and that's because is raining is set to false, and therefore this says if false, so it won't then do this code and it will jump through. And IntelliJ even tells us it's saying it's always false, so you don't even need this. We're not going to remove it like it says, because we're just trying to learn at this stage. What I'll do this time is I'll change it to true, okay, and we'll run it, and we'll see that this time we get our message saying take an umbrella. There we go. So that's reasonably straightforward. We don't always, we don't always just want a boolean value. We might want to do some kind of comparison. So let's try something different. So we'll get rid of our is raining, and in fact we'll start again right from scratch. And this time we'll what age? You can retire at 67. So we want to present a message if someone happens to be at the age of retiring. It might be 68. I think it's 68. Let's go with 68. So what we might do is ask the user to type their age. So you can do that by creating an instance of the scanner. We'll call it scanner, and we'll say it's going to be a new scanner, and we'll get anything that's coming in from system.in. And then we'll create an integer value, and we'll say that's age, and that is going to go to the scanner and ask it for the next integer. Okay, now obviously this is not very helpful unless we tell the user what we need them to do. So we'll ask them to please type your age. We'll read that into the age variable, and then we can write an if statement that says if age, and we can compare our age integer with a given value by using the double equals to compare. So we can say if age is equal to, I think we decided it was 68, age of retirement, and then we can write some logic. So we might say you can retire this year. Okay, so the thing to note, and a common mistake that I see made, is where the wrong version of the equals is used. So we use a single equals to assign one value to, for example, a variable like here. So here we're assigning the value that comes from the scanner into the integer variable called age. With two equals, we are saying is age equal to 68. So I tend to remember this as age is for 1 and is equals for 2. But it doesn't matter how you remember it, as long as you can remember that that's what's going on here. So if we try this and run it, whoops, I have the documentation over there. So please type your age. Well, let's say we're just starting university straight out of school. We'll type 18. We don't get a message, but if we run it again, and we come back and type our age, and we are 68, it will tell us that we can retire this year. So that's well and good, but there are other things we can do. We can we don't have to check if something's an exact match. We might check, well, are they, for example, over the age of retirement? So to do that, we might say, is their age greater than 68? Now we have to be careful here, because it takes a very literal interpretation. So if we're saying, well, are we over 68, the computer will interpret that as being, are we 69, 70, 71, so on and so forth. So let's just try that. Let's just see what happens. We run it. We type an age of, say, 60, or let's go for 80. We can retire, except the message is now wrong. We probably want to say, well, actually it's still fine. If you're still working, you still could retire. You can, or may have, retired. But the problem comes if I type 68 here. So let's try that. And we don't get a message. So the important thing here is that we need to make sure that we either, and this is not necessarily the best option, we could say, are they over 67? But because 68 is kind of the figure that is given, what we can do is we can say, well, are they greater than or equal to that value? So if we run that now and we put in a value of 68, we'll get a result. We'll get the code inside our if statement runs. Just a couple of things you might have seen in course books, or if you've learnt Java before, you can do something like this. You cannot drink alcohol, or buy alcohol, probably more correctly. And there's no braces here. Okay, this works. Let's try it. Okay, but it's easy to make a mistake and to add another line under here and think it's within that if statement. Okay, because this only works for a single line. So what I'd strongly advise you to do is always put your if statement things in braces. If you need more than one line, you know, you are a child, you've got to have the braces anyway. So it's a good idea to get in the habit of putting the braces in. There we go. Okay, so this greater than or equal sign works for both ways. So you can have less than or equal to if we wanted to. Obviously in that case we'd do 17. Again, it doesn't quite make sense to do 17 because 18 is the value that is normally the one that is spoken about. So in this case we'd probably say less than. So that's greater than or equal to. What else can we do with if statements? Well, sometimes we might want to check that some condition is not met. Okay, so let's say what 68 is the year you actually retire. So we could say, for example, if age, and if we wanted to say that either you're still working or you have retired, but it's not the year you could retire. Okay, we could say that, is it not equal to, and then we can put 68 in, and then we can print out a message. So this is not the typical year for age to retire. Okay, so let's run that. We'll try it. If we put in something that's, you know, below 68, 65, we get a value. If we run it again, put in a value above that, so we'll go for, you know, 80. But if we put in 68, that statement evaluates to false, so it does a check and it returns true or false essentially, and therefore it returns false and we don't go into it. So the thing to bear in mind is whatever goes inside the braces must evaluate in some way or other to true or false, so that the result of testing this is always going to be true or false. Is something greater than something else? Is something less than something else? Okay, you can store these values in a boolean if you want. So you could say boolean what are we saying with not 68, not at retirement age, and we could specify that that is essentially this. So we could copy that from there, paste it there, and then we could say if not at retirement age. Okay, you don't actually need the brackets when you put it here. I mean, I'll just show you that this still works. So we'll put in an age that's not 68, so 15. There we go. It takes it, so this turns into true or false, and then this will either be true or false. Okay. Yeah, so you don't need the brackets. We could take those out, and it will still work. But this looks kind of confusing. We're used to doing the things that appear in brackets first, and therefore, when we take the brackets away, this statement becomes a bit hard to read. Whereas if you put this in, at least for us humans, it's easy to work out. Okay, we do this first. That essentially becomes either true or false. So true or false, depending on what age is. Okay, and then here it's just a true or false. This is always, the thing in brackets always has to be eventually something that works out to true or false. The other thing we could do is we can actually invert the value of a boolean. So let's say we are we've got a boolean that says could you retire. So obviously 68 is the age you typically retire. I think for most people nowadays, apart from those who are close to retirement, you can take early retirement from, I think it's now going to be 57. So we say could return, and we might say that's equal to the age being greater than or equal to 57. Okay, we'll get rid of that comment for now. But we might want to do something that only happens, so let's say if at the moment I say could retire, and we could print out a message that says you could retire. But let's say I'm not interested in telling someone if they can retire, I want to say that they can't retire. Okay, now I could, for various reasons, just flip this around, but let's say for whatever reason I've got this value here, could retire, and it's come from somewhere, and at this point it's not straightforward to change it. It is obviously, but imagine for a minute it's not. What we might want to do is to say, well, if we couldn't retire, okay, we want the opposite, like the not of whether we could retire. So our message should be you can't retire yet. Okay, and the way to do that is we could do it two ways. One of two ways. The better way is to use the exclamation mark and put that before could retire, and that means not. So we used it for not equals, exclamation mark equals. We can also say not and a boolean value. So now this is saying if we could not retire, so not could retire, then it will print out a value again. We can test that and see the result. If we type our age that's below the minimum retirement age, say 45, we're getting our output. Okay. The other way to do it, I see this a lot, it's not ideal, is you could check whether could retire is false. Okay, and the result of checking if could retire is false becomes true, which is the same as saying if something's not false. And it's even telling me here, well, okay, you've written could retire equals false, can be simplified to not could retire. So it will work, but it's not the recommended way of doing it. So there we go. Just one final thing that does happen. Let's say we're going back and we're doing it so you can retire. So you can retire. We're not checking for equality of false. This is either true or false, but what sometimes people do is they check if it's equal to true, which has no effect. So let's just prove it. If could retire, we'll put in a valid retirement age of say 75, 70, whatever. What's my mouse cursor? Here we go. 70. People write this equal true. There's no point doing it. You're basically saying if true is equal to true, which is kind of pointless. All that needs to be in here is a true. So let's run it. Same result. and it's also probably saying we could simplify it to take away the is equal to true. Okay, and if you want to use a little action, you click simplify, and it will take it out for you. Okay, so that's a brief introduction to if statements.